UM Manfred Olson Planetarium. My name is Victoria Robison and I'm the Assistant Director. Thank you so much for joining us tonight on this cold night. We're very excited about the events of yesterday. The Mars rover landed, and so tonight's show will be extra special. Join me in welcoming your Mars guide, Dr. Jean Creighton.
Hello, and thank you for being here tonight. We are very excited. I am wearing my lucky NASA jacket just because I feel the real excitement of landing successfully a rover on Mars. So today we are going to talk principally about Perseverance, although I should say there have been 3 missions to Mars this year so far. And this one launched on July 30th, 2020, which means it takes, about 7 months or so to travel the distance between us. And what you're seeing here is part of the team. There are about 1,000 people involved in this project. And it's wonderful to see the kind of the seasoned people on Mars exploration with all the new people that have joined as well. Before we get into more about this amazing adventure, I think it's important to sit back and wonder, why are we sending machines to Mars? Why are we interested in Mars? There are 3 reasons. The first one is we want to understand more about how planets form. This helps us understand the Earth. It also helps us understand planetary systems around other stars, right? What we call exoplanets. But what I'm going to focus today is the 2 other reasons. That is the search for life. Could there have been life on Mars before? Could there be life on Mars right now? And also, to get machines successfully to Mars, and certainly to get people to Mars, there's a series of problems and challenges that we're going to need to address. And that leads to, important innovations that can be useful on Earth and change our life.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the sands of past life.
I'm just going to share a couple of thoughts I have about this particular scene, because I have been in a similar situation with a satellite launch that I was involved in some years ago. And what I'm seeing here is a bunch of people who have spent, in some cases, a few months, in some cases, though, many years, maybe their entire career, toward this moment. And it is a moment because last week and last month they were working hard, and the next few months is going to involve a lot of work and crises and things. They take a moment to actually just feel that relief that, okay, it landed. Notice that, well, you'll see in a moment that 50% of Mars exploration missions do not succeed. So it's not a given. Our success rate is getting better with time, but I'm just saying this is not easy. You can't take it for granted. So that moment of like, yes, we got there is really exciting.
Jean, I'm going to interrupt you real quick. I think that your screen is not sharing.
Thank you for letting me know. Thank you. That would be good. It would be good if it's shared. Let's see. Well, I guess I'll have to show it then back. Let me just go back to that. And okay. So I guess we'll see it again and I won't say the same thing.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the sands of past life.
There's something else, of course, that's a little weird about this. I know what this normally looks like. People would be hugging and kissing and jumping and crying. And of course, now they're trying to be distanced, but that is necessary at this point.
And I think that you are sharing your whole desktop now. So maybe, yes. Luckily, we're not part of the Mars rover
focus.
landing team.
I need to focus. Okay. All right. Wow. Okay. I guess I am really excited. These are some of the first few pictures that we took on Mars. And I'm going to be using we, and I don't do this to take other people's credit because obviously I had nothing to do specifically with this mission. But I feel like this is a victory for humanity. This is a wonderful opportunity. So please permit me, we, even though I'm telling you I had nothing to do with the mission Perseverance per se. Now, I said 3 goals. We're going to talk about 2, specifically life on Mars. Could there have been life on Mars? And it turns out that in the last 60 years, there have been 59 missions from 7 different space agencies / countries. And 29 of them have been successful. 10 are still operational. We have a fleet, if you will, of 5 orbiters and 2 newcomers. One is Hope from the United Arab Emirates that is just arrived a few weeks ago, going around Mars. And Tianwen-1 is a Chinese effort that will also involve eventually a rover landing on Mars. In addition, there is a lander called InSight, which basically lands where it is and boop, that's where it is. And we have Curiosity. And Curiosity has been joined by Perseverance, and we'll see also a little helicopter Ingenuity that Perseverance has as well. So there's a whole fleet, literally, of machines that are kind of monitoring and investigating Mars. Notice, for example, that the Mars Reconnaissance Orbiter has been there for 15 years. We have very fine maps of Mars. The first time that we successfully landed, we had what we call a soft landing on Mars, is Viking 1 in 1976. And there's a gorgeous picture that shows us the ground for the first time that we saw Mars. This, of course, I'm sure the engineers understood was an amazing accomplishment, but it became even more amazing in hindsight because it took 20 years to do that again, to have a soft landing on Mars again. After a few failures, finally Pathfinder in 1997 was successful, and it had a proof of concept on board called Sojourner, which was about the size of a shoebox. And the shoebox had a rover that could move, which meant that you could photograph not simply the landing site that you were, but you can also send your little scout to find other cool places to photograph and investigate. The rover was so successful that a whole family of rovers followed. Opportunity and Spirit were twins. Opportunity landed in 2004 and almost immediately hit the jackpot because we found these what have been known as blueberries, but of course they're not blueberries. This is a false image just to show them, to highlight them. What they are is hematite. And if you were to look at them with your naked eye, they would look like what you see on the right-hand side. And this is iron and oxygen mixture, which means this particular compound, hematite, forms in large quantities of water over long periods of time, which tells us conclusively that Mars used to be warmer and wetter than it is today. After all, the average temperature on Mars is 150 degrees below freezing, which makes the day like today of Wisconsin positively balmy. In addition, Mars is very dry now. If you took a glass of water and you tossed it toward the ground, it would evaporate before it hit the ground. So clearly now there couldn't be standing water on Mars because of the circumstances there now. The twin of opportunity, Spirit, landed on the other side of Mars, and it was able to photograph for the first time a dust storm. Dust storms are a problem on Mars because, especially if you're relying on solar panels to get your energy, if too much sand is deposited on your panels, then you don't have enough energy and you can't turn on, right? You could finish your mission this way. So that's frankly why the next sister, Curiosity, that came through is nuclear powered. Curiosity also has a small lab on board, which enables us to do experiments that we wouldn't be able to do otherwise. I should point out, I heard one of the engineers talking about how proud they were of this particular picture of Curiosity. It shows Curiosity a little weathered, a little dirty, a little dusty, but this machine has been working on Mars for almost a decade now. So of course it's going to look a little rougher for the wear, but it's still soldiering on, which is wonderful. We're going to hear from an astrobiologist how Curiosity has been used to analyze samples on Mars.
Sam made the new detections by heating samples of crushed rock to very high temperatures. This vaporized the samples and released several species of small hydrocarbons like benzene and propane. Because the hydrocarbons were released at such high temperatures, they may be the fragments of bigger, heavier molecules within the rock similar to kerogens. On Earth, kerogens are found in rocks like black shale and coal and are the products of ancient plant and bacteria. In the distant past, Mars was much warmer and wetter than it is today. The discovery of ancient organic molecules shows that another ingredient of life was present at that time, and it broadens our understanding of habitability of both ancient and modern Mars.
The question now is, could there be life on Mars right now? And to answer that, I'd like us to think for a moment, if we were Martians, if we lived on Mars, how would we know that there was life on Earth? You could say, well, we would see oceans, and that's true. The Martians would know that Earth has huge quantities of liquid water, so they would know without any doubt that Earth is warmer than Mars, for sure. The other thing that they would see is that the atmosphere of Mars, of Earth, has both oxygen and methane. This is a clue because both of those gases are so light that left to their own devices, they would just float out into space. And the only reason why we still have oxygen and methane in the atmosphere is because we're constantly replenishing them from life, right? So plants, of course, animals make a lot of oxygen, plants primarily, and also diatoms in the oceans. The methane, however, is made by the animal that really gives its name to the dairy state that we live in, and that would be cows. It is the farting of cows that would give away that there is large life forms on Earth. And there it is. So imagine how excited we get when we see that the amount of methane in the atmosphere of Mars changes with the seasons, and it seems to peak at the height, or I should say, at the end of the summer, compared to what it's like at the end of spring. Well, that could be because there's underground volcanic activity, right? No life there at all. But it could also be that there's microbial life in the soil of Mars. And that is the very reason that we have excess seasonal methane on Mars. This is still something to be determined. Now, I realize that I've been very excited, so I'm just going to check and see if people have any questions. I see none, so I'm going to carry on then. I will carry on, but I'm understanding that I'm getting very excited, so I should move on to Perseverance as a machine that is now bigger than a person. So we've come a long way from shoeboxes. There are 27 different cameras on Perseverance. And the reason for that is not only to photograph things on Mars, also to photograph itself to make sure that everything is working as advertised. And also the guiding system requires cameras. And that is what allowed Perseverance to have an ambitious landing location. The other thing that's absolutely brand new on this machine is a caching system. So this is going to bore holes in rocks, take samples, and set them aside for what we call a return mission. I'll also point out that the wheels that you see are completely redesigned just because previous rovers' wheels got seriously ripped because the rocks on Mars are so sharp. There are 4 scientific goals that Perseverance has. The first one is to look for additional evidence for habitability. That is evidence that this is a friendly, or I should say, it has been a friendly place to life in the past. Even better, it would be to find fossils of life. That would be the best, what we call biosignatures. I mentioned the caching samples, which, is going to sort of necessitate 2 more missions, which I'll mention briefly. And for the first time, a rover to Mars has as explicit goal to prepare for human exploration, which, as I mentioned, is not going to be possible probably until 2040, I'd say at the earliest. In the belly of Perseverance, there is a small helicopter. I think it weighs something about like 6 pounds. It was named Ingenuity after a high school student called Vanessa Rupani. And its mission is, first of all, a proof of concept. Can we get a helicopter flying in the atmosphere, the thin atmosphere of Mars? Furthermore, we need to map as best we can where are promising places for Perseverance to get samples, but also what are places that are best left alone, that are a little too dangerous, too rocky. All of these rovers have a certain tolerance to go over things, but in some cases, if it's just too dangerous, you just want to avoid that altogether. So here is little Ingenuity. As any time you have a proof of concept, this is not mission critical. So if it turns out that it doesn't work the way we were hoping, it's not going to affect the principal goals of the mission. If you take that beautiful map of Mars and flatten it out, it is possible to see all the locations of landers and rovers that have come to Mars before. Many of these locations are pretty boring, actually, pretty flat, pretty uneventful. And the reason for that is you want as simple a landing spot as possible to increase your chances of success. In the case of Perseverance, the location that was chosen was more challenging than would normally be acceptable. Jezero Crater, it's called. But the reason that they allowed it was because of these photographs that they could take to reassign the exact location that they would land if it turned out that it was too dangerous. Jezero Crater is a dry river delta. You can see on the lower left side, we have a dry riverbed that obviously used to have water at some point that spilled in a fairly shallow lake. And given that on Earth, this is a river delta of the Nile, it's teeming with life. We think that this might be a promising place to go looking in the definitely one of the better places on Mars to check out. It would be even nicer to find fossils of life. Now, the problem is that fossils, especially of microbial life, is not so easy. It's not obvious. And the only way you can kind of understand what it might look like is to see what it looks like on Earth. Some of the oldest fossils of life on Earth are in Australia, more than 3.5 billion years old. And what we're looking for is what we call stromatolites. And we'll see some here in Australia. And they'll give you a sense of this is not obvious.
This is precisely the kinds of signs of life that we'll be seeking. The rocks you see right in front of me here, these wrinkly layered structures that we call stromatolites. Structures like this actually represent fossilized microbial mass, basically fossilized pond scum in a sense. Microbes, bacteria living in a shallow water environment, and we believe that if life ever existed on Mars, it would have been purely microbial.
For the caching system, what we're hoping to do is send the rover to various promising places, have samples put in sterilized little tubes, and then set them in a particular location for a return mission. I happen to know that this return mission to Mars is being planned right now, and the hope is that this mission will be accomplished within the next 10 years, around 2030. We'll collect samples and bring them back to Earth. And the reason for that is that the labs that we have on Earth are much, much, much better than what we could possibly send on a rover to Mars. Finally, we're preparing for human exploration, and therefore we definitely need to solve the problem of the oxygen. And the reason for that is you couldn't possibly bring with you all the oxygen that you would need for a 2-year mission. So what we have on Perseverance is called MOXIE. It is a proof of concept where basically you take carbon dioxide, of which there's plenty in the atmosphere of Mars, and you use electricity to break the bond between carbon monoxide and oxygen. And if that's successful, then the expectation is that we would just ramp up the program and be able to create more oxygen for breathing and for fueling the return home. I don't want you to imagine that we're going to sort of move our wand and make Mars into Earth. That's simply not possible. What we imagine happening is that we create little biospheres that people could live in comfortably, at the right atmospheric pressure, oxygen, temperature. So that's the goal. To talk a little more about what we need to make it possible for people to go to Mars, we're going to use a list that was made by Matt Damon's character in The Martian, an excellent movie, and the book is also excellent. I recommend them, to see what problems would need to be addressed before he was going to be picked up. He was left on Mars by accident, and he had to survive until such time as people come and get him again and bring him back home. The first question we've already asked about is the oxygen issue, so hopefully MOXIE will help us with that. The second is the food. I'm guessing it will be impractical and undesirable to bring all the food that you could want in 2 years with you that some of the food would need to be grown on Mars. I did mention blueberries for alert listeners. Of course, those are 100% rock, nothing that people could eat. If you look at the soil of Mars or the soil of the moon, its composition, we think that we would be able to grow food on Mars. In fact, if you're interested in this kind of thing, I'm just putting in a plug that this coming Wednesday, we have an expert at 7 o'clock Central who will be talking about farming in space. I do happen to know that we think with the soil on Mars, we would be able to grow things like, say, asparagus, but not strawberries. So keep that in advisement. Now, the fact that it's possible to grow food doesn't necessarily mean that it's safe to eat. After all, the top layer of Mars is fairly radioactive. You would need to remove that to grow food, and you would need to wash very carefully any produce that you produced so that you could remove the calcium perchlorate, which is, after all, toxic to people. There's also this issue of whether the food is acceptable. We are perfectly aware that for a couple of weeks, people are willing to eat things that they would not be willing to eat for a period of 2 years. So there's a whole crew of research that's happening on identifying foods that could be acceptable to astronauts for long periods of time. The psychological isolation, we're now more sympathetic, more knowledgeable, sadly, since we all have experienced some isolation with the global pandemic. But imagine having everybody you know and love on a different planet. Imagine that you're so far away that it takes 20 minutes to get a signal from Mars to Earth. It's a little mind-blowing if you think about it. And in particular, it's mind-blowing for astronauts that they really cannot get help the way they normally do if there's a problem. That's what's scary. That's scary for everybody. That if you send a message, I've got a problem at 7:20, it'll take 20 minutes before that message gets rebroadcasted to Earth. And even if they respond right away, it'll be 40 minutes before any information is exchanged. And depending on the problem, that might not be good enough. I mentioned radiation already, and radiation is one of the main problems of sending people to Mars that we don't have a solution for. On Earth, our planet is protected by its magnetic field. Mars doesn't have a magnetic field to speak of, which means that the radiation would hit the ground in a big way, in a deadly way, which is why we are designing a vest that's going to be tested on dummies that are going to be aboard Artemis 1. Artemis 1 is flying in November of 2021. And the idea is that the dummies are going to have instruments that measure radiation, and hopefully that the measurements are going to be lower on the dummy that is wearing the vest. Artemis 1 involves a brand new launch system, if you want to call it a brand new rocket. It involves a brand new capsule. So that's going to go all around the Earth, and it's going to head toward the moon. And the idea is to do a dry run. Nobody's landing. First of all, there are no people in Artemis 1. There will be people by 2024. But for now, we're just making sure that the equipment works the way we expect, that the maneuver is possible. There is a lovely little capsule coming back. It's called Orion, and that will land on Earth, and hopefully everything will go smoothly, and that will be a major test. This is similar to what Apollo 8 was for Apollo 11. So here is Apollo 1. I'm sorry, I mean Artemis 1. I love always thinking ahead. I like thinking, planning, and we're already thinking about a program that we will offer when Artemis 1 is on its way to the moon. But back to Mars, the spacesuit that you're seeing Matt Damon wearing here looks good, but it probably wouldn't be good enough for Mars at the moment, nor even is this the suit that the astronauts aboard the SpaceX rocket that went to the International Space Station. That wouldn't be quite enough for the radiation on Mars. We probably would need something that looks a whole lot more like what the astronauts wore in the Apollo missions. It's called Artemis XMU, the new version of it. And I know it doesn't look a whole lot more elegant, but the fact is that it has a much better communication system. And more to the point, its joints are much more nimble, which means that the astronauts don't need to be kind of fighting to move around on the moon like that. I talked a little bit about habitats on Mars. And for the last, I think it's been over 10 years, multiple countries have had experiments. We've been wondering what happens psychologically to people when you enclose them in a small space with limited resources, a small group of people. How does that work? And an experiment was done on the big island of Hawaii called High Seas. In this case, there was a group of 6 women who were investigating the kinds of psychological issues that come up. You see an indoor picture, a panoramic view of their working and living space. And this is all the food that a group brought with them for a 3-month stint in High Seas. I'd like to point out that although some of the dwellings that we imagined at some point on Mars were underground, we have come to appreciate the importance of natural light. Furthermore, people liked the idea of building something that could be there when the astronauts arrive. And that's how a 3D printed dwelling came into people's imagination. This particular one allows for natural light, and the prototype has been built in New York State. I hope to have impressed upon you that going to Mars is going to require a lot of innovation, new technologies, new ways of conducting agriculture, even waste management. Obviously, we're not going to go to Mars and just dump junk. Everything you bring to Mars is very expensive. So you have to think very carefully about what you do with every single thing you bring with you. And it better have multiple purposes. And again, we don't want to trash Mars. I'm happy to say that there's research around the world about these various these issues, and that I'm happy to say that UWM, the University of Wisconsin-Milwaukee, is definitely part of this effort. Janice Els, for example, is an expert in the health of the eye. People who would go to Mars would almost invariably have too much radiation hitting their eye, and we're finding ways of treating those kinds of injuries with infrared radiation. What's cool about that is that as a result, we have found that it also helps with conditions like macular degeneration that affect millions of people on Earth. Ronnie Al-Hajar is an expert in composite materials, and he is investigating what kinds of materials are suitable for 3D printing that are also space worthy. Nathan Solowitz is part of a large lab that is involved in what's called self-healing metals. When I first heard that, I thought, what? That sounds pretend, but in fact, it's true. You can make metals that can identify damage that they have and ways that they can heal themselves. So if you go to Mars, chances that your spacecraft is going to be hit by some micrometeorite are pretty good. You want to make sure that whatever damage is done is addressed quickly. First of all, that somebody knows and it can be fixed before it becomes more of a problem. So all of these technologies enable ultimately us to be able to go to Mars, right? But also they are finding ways of helping life to improve on Earth. Self-healing materials and 3D printing is going to become much more common, I would predict, in the next few years for us all. And with that, I would like to thank you very much for joining me. I would like to thank specifically Victoria Robinson, who takes care of a tremendous amount of technical aspects of the program. I would also like to thank the University of Wisconsin-Milwaukee's College for Letters and Science and the Center for Gravitation, Cosmology, and Astrophysics. And with that, I would be happy to answer questions. I will stop sharing my screen and hopefully I'll be looking at questions, of which I guess there are several.
Like there's a lot of questions. Do you want me to
Oh yeah, go ahead. Yes.
Let's see, I'll scroll back here. We have many good questions. Eric asked, how long will Perseverance stay on Mars? A question from Emily, actually.
The hope is for at least a year, but I think we would be surprised if it didn't last longer than that. There's a history now, a precedence of these rovers outlasting their expected lifetime by many, actually factors of 10 or more.
We have a question from Jessica. How many robots went to Mars and which was the first robot on Mars? Or rover, I suppose.
The first rover was Sojourner in 1997. The very first machine that flew by Mars was in 1965, I think, Mariner 4.
We have a question from Janella. Is it concerning that there isn't any water anymore?
Concerning. It does tell us that things can change, and that's a good lesson for us to remember. What we think has happened is that the atmosphere on Mars got basically stripped by what we call the solar wind from the sun that kind of constantly put a drag on that atmosphere, and over time it made it much thinner than it is today.
We have a question from Pratiki. Hi, Jean. How long did it take to build Perseverance? Thank you.
That's an excellent question. I don't have the answer to that. I don't have that handy, but if I had to guess, my guess would be between 2 and 3 years. But one has to remember that these rovers are built incrementally. So what I mean by that is we have a design. Okay, that works. Good. Now we're going to tweak it a little bit. We're going to make this a little bigger, a little this, a little that. They know from performance. I told you the wheels were redesigned because the previous wheels were getting ripped to shreds. But all these changes are incremental. And I was kind of thrilled to see that there is a woman, and I don't remember her name, but she's been working on all the rovers since Pathfinder. So she's been involved in all the rovers. So that wisdom that people acquire is kept, people keep it. And she's an expert on thermal properties. Because Mars gets so cold and electronics doesn't like that, you have to make sure that certain critical pieces of the rover gets protected. So that person, the lead for thermal properties, has been the same.
That's amazing. Let's see. We have another question from Janella. Why are cows most effective at releasing methane compared to other animals?
Because they eat all the time. And there are a lot of cows on the planet, to be sure. There's a very large industry of cows, but yeah, they just produce a lot of gas. What can I say? They're eating grass, and that's heavy on the system, that you need a lot of work to get that processed.
Sunshine has a question. First she says, thank you so much for all the information. How much is the cost to build it and cost for the mission, and who is sponsoring it?
Maybe I'll ask Victoria to Google that. I don't have the number handy. I would guess it would be in the hundreds of millions of dollars, high hundreds of millions of dollars, but I'm not sure.
I'm getting something more in the billion territory. Billions.
Not surprised. I said high hundreds of millions would be my guess. Yes. Who's paying for this? Well, NASA has, I'm assuming this is principally in NASA's budget, but many of these projects are joint projects. So multiple nations pool money together, or space agencies, to make it come together.
Jared's question is, what happens if a rover becomes damaged? Is there any way to fix the damages?
It depends on the damage. It's surprising what you can do with software. It's surprising what you can, well, I guess I'll answer this in two different ways. First of all, people try and fix it, right? They try and accommodate, they try and fix what they can. But there are times when you can't fix it. Like in the one of the wheels of, I think, Opportunity got stuck, wasn't going to move. Well, you can sit there and cry, or you can say, okay, well, how am I going to use this to my advantage? And then they started understanding, they started looking at how, like, when it spins its wheels literally, which means that you get to see a layer of the soil that was below what you could see before. So they tried to make the most of a situation. I've seen this done several times, where people try and make lemonade out of a lemon.
I'm going to combine these two sort of related questions from Jessica. Were there plants on Mars? And if there was still life on Mars, would there be animals on Mars?
As far as we know, we have no evidence that there have been, never mind now, we don't even have sure evidence that there have been plants or animals in the past ever of any kind. But we're hoping that if we can get people to Mars, we would be able to grow some food there.
That connects to another question we have from a member of the Creighton family, looks like, Teviot. Can you grow leafy greens on Mars?
I'm not sure, Tevi. Here's what I know. I know that on the International Space Station, one of the very first experiments and continuous experiments that they're doing is to grow greens in a chamber, because it's one of the things, as you can imagine, that the astronauts long for, something crunchy, for something fresh. I understand that if a couple of strawberries come with their resupplies, there literally is a party everybody on board comes together, they make crepes. I mean, it's a real celebration because getting fresh fruit and vegetables is hard. So I think the green, since it can grow in the International Space Station, I assume you could grow green leafy things on Mars.
We have a question from Sean Kurtz. I guess, I think Sean was here for Wednesday's program too.
Yes, he was.
We have a diehard fan. Are there any applications of the self-healing metals used today?
I think the answer to that, Sean, is yes, but I couldn't tell you what.
Let's see. James has 2 recommendations for fans of Mars. Terraforming Mars is a brilliant board game, and The Habitat is a podcast about the High Seas mission. I'm definitely going to Google that right away. Do you have, his question is, do you have any thoughts on potentially terraforming?
I think it's going to be impractical, not to mention exceedingly expensive. I think we're going to, if any groups of people live on Mars, they're going to have to figure out how to do that in enclosed spaces.
A question from Nathan. What kind of extreme weather on Mars would affect habitability for humans?
Cold, 150 degrees below freezing becomes dangerous, right? Dangerous. Not only you can't be outside in those temperatures, but even if you could, you can only be under certain circumstances. You have to have every little bit of yourself covered. Infrastructure falls apart. I mean, never mind the people, it's also your equipment that can damage. I mean, my brother is an engineer, and he works for a company that has, operations all over the world. And he was telling me that it gets really hard when you have extreme temperatures. So he has a location, I guess, somewhere in Kazakhstan where the temperature varies from -40 Celsius to +40 Celsius routinely. You have to be prepared for those temperatures. That's nothing like 150 to +20. So most things, most metals, most plastics, most electronics aren't really built to do that. So notice how, and I don't say this lightly, but an unexpected snowstorm can take out power grids and can get people pretty miserable pretty quickly. Imagine in a place where, probably if you were without electricity for a day, everything would freeze, and that would be that. So extreme temperature is scary and should be taken seriously.
I think you just answered this too. What is the max temperature on Mars?
The max, I think, temperature, the height of the summer is 68 degrees Fahrenheit, which is about 20 Celsius.
That sounds pretty good to me right now.
That sounds excellent, yes, but it is a sort of a heat wave.
And Heather wants to know, does it snow on Mars?
I think the precipitation from the sky doesn't happen, but there are frozen. If you look at the south pole of Mars, there is a polar cap that kind of grows with the seasons. Carbon dioxide can freeze, and you, as I said, you see that white spot that grows and shrinks depending on the season.
Let's see, we have a question. What would happen if someone ate vegetables from the toxic soil?
I'm not sure how quickly it would kill you. If it's something, I don't know. I didn't get the sense that this is an instant poison, boom, you're dead. But I suspect that over time it would accumulate in your body and it would cause problems.
We have another question from Tevye. What is new about the wheels on Perseverance?
I think it has to do with the materials that the wheels are made of, but also the spokes are differently designed. I haven't looked at this in any kind of detail for a while, but they really had to scrap the design they had. And this was a case where they were trying to fix it in real time. So they were doing little experiments in their sandbox at JPL to figure out, is this better? Is this better? They did experiments and they came up with a design that works better.
Let's see, a question from Brenda. When will Mars be habitable? And I'm just going to fold in another question. Will anyone be able, when will people be able to go to Mars?
So I tried to communicate. I know people ask me about terraforming. We're not going to be able to change Mars to a habitable place just like that. We're hoping to get people to Mars in 2040. And when I say people, I'm not talking about droves of people. I'm talking about 5 or 6. I don't think that in my lifetime we're going to have, large numbers of people going to Mars. What I will say is that there was a company called Mars One. I'm pretty sure they've kind of shut down now, but something like 10 years ago, they were trying to collect money to send people to Mars. One way ticket. And they put out a call for volunteers. They had 700,000 people volunteer for a one-way ticket to Mars.
That's a little frightening. Wow.
Yeah. And that we weren't even in a pandemic. I don't know what they would do now.
Let's see. Hola Razmataz. How did they get the name? A couple people have asked, how did they get the name Perseverance?
A lot of these names happen as follows. The mission is called Mars 2020 for years. I mean, that's what all the people who work on it call it. And then one day, and I don't know exactly when, maybe a year out, NASA says, okay, people, we need to come up with a better name. Oh, okay. So usually they put out a call to high schools or to the public or both. And they say, okay, give me some names. And they shortlist, 50 or something. And then they kind of down select. They probably use their social media channels and so on. Perseverance was another, I think it came from also a high school student.
Nathan asks, what kind of cool landmarks have been discovered on Mars?
Cool landmarks. Well, let me think. I'm not sure what. So craters, dry riverbeds, highlands. I'm not a geologist, so I couldn't tell you about specific rock crops, but people who do this can tell you, oh, my favorite is, and they have a name, they tell you about a rock, the specific thing that they name. And I actually had dinner once with somebody who, she drives a rover on Mars, and she said she knows the geography of Mars better than she does that of Earth. And I thought, awesome. Frankly, I don't know. I wish I knew the geography of Earth better than I do, but I certainly don't know Mars that well.
Kind of related, we have a question from Yug, asks if there are ice volcanoes on Mars. I think this was another person from Wednesday.
Mm-hmm.
Really
That's
hard.
very flattering. The people are back for more. There are extinct volcanoes on Mars. And I guess to answer the previous question, we haven't sent rovers to volcanoes specifically, but there are 4 very tall mountains on Mars, one of which is the biggest. Olympus Mons is the largest mountain in the solar system.
Angela asks, can you suggest any more resources to learn about the self-healing metals?
I would Google it. That's where I would start.
I like these couple questions here. Do things smell the same on Mars as they do on Earth, and taste, for that matter? I guess you'll have to use your imagination, Jean.
Yeah, that's an excellent question. My guess is not, because the smell travels with the particles of the atmosphere. And if the atmosphere is much thinner, and drier, my guess would be that your sense of smell would be reduced. That would be my guess. But I could be completely wrong about this. It could be that because the density of the air is lower and gravitational pull is a little less, maybe things travel more easily. I'm not sure. That's an excellent question.
How about this one? What about 5G? Are you going to get a 5G network on Mars?
I doubt it, but I think that that's one of those things that they'll have to do the cost benefit analysis. What do you really need?
Heather asks, is gravity the same on Mars as it is on Earth?
Well, gravity is connected to how much mass is involved, and Mars is smaller than the Earth. So you'd be looking, if you weighed 100 pounds on Earth, you'd weigh something like 40 on Mars. So because it's the mass of Mars is smaller, you would be lighter.
I think we've gotten to the end of the questions here. We can give it a couple more minutes to see if any others come in, but I guess we're getting to the top of the hour. Any last thoughts you want to share, Jean?
I just think that we live in a really exciting time. I realize that there's a lot of problems, a lot of concerns for many things. But sometimes it's nice to be able to imagine that we have the curiosity and the wherewithal and the smarts to have groups of people, teams of people, build something that can go all the way to Mars and land safely and explore. I think that's pretty uplifting. And that's a useful thought to have in a very cold February day.
Yes, as Angela has said, I think this is a rhetorical question. How cool would it be to send something to explore a volcano on Mars?
Very cool.
That sounds cool. I think we have one more question here. Does an astronaut's helmet fog up when he breathes too much? Just like glasses.
I assume not. It's exactly the same as when long before pandemics, surgeons have to wear masks and their glasses don't fog up. This technology exists. There are special things you can put on glasses that this doesn't, not a problem. I assume that astronauts have figured that out. What is true, though, is that sometimes there have been issues with water, and that's dangerous. That can be dangerous. So that, so again, space is a dangerous place. You have to, one small thing goes wrong, and all of a sudden you have a life-threatening situation. So you have to have your wits about you, and that's when having that connection with Earth, that quick connection, really helps, because people help you work the problem, is the expression.
We have a really heavy duty question here. Can you explain how to separate carbon dioxide to O2?
Well, what they do is they basically use a catalyst. They have an anode and a it's funny, sometimes my English just kind of escapes me. The positive charge, the negative charge in a battery, and they have to really put some serious power through that battery, but it literally breaks the bond of carbon monoxide and oxygen. It breaks the molecule in half, and that releases a very small amount of oxygen. I think the experiment is designed to produce something like, 10 grams of oxygen, something fairly trivial, but it is a proof of concept. And if it can work, then they can scale it up and produce more oxygen.
Razmataz says, I've heard algae may one day be used for rocket fuel. Is that true? Have you heard anything about that?
I'm not aware of that, but that doesn't mean that's not a thing. I'm sure that people are looking at all kinds of different fuels. The reason why oxygen is attractive is because oxygen and hydrogen can make fuel together. So they can produce a lot of energy, which can power your return craft. But as you say, there could be other solutions as well.
We have a couple of thank yous. It looks like we have some kids in the audience. Yug loves joining the show and has another question. What happened to the jetpack after dropping Perseverance?
It stays on the ground. You mean the little balloon, the little balloons that yeah, they're just left on the ground, which is kind of handy because that means that the orbiters around can photograph it and check and see, is it where it was supposed to be? It helps them model or check the models that they had in terms of the landing sequence. So I really do think it's awesome that we have so many machines orbiting Mars that now not only can we photograph Mars from Earth, but we can really take beautiful pictures and find, dropped things, missing things, broken things by machines that travel around Mars.
We have a thank you from Kitty. Thanks for joining us, Kitty. I think we're past 8 o'clock, so maybe I don't see any more questions here. I think I got them all. So yeah, time to wrap it up.
Okay. Well, again, please look on our website. We have lovely programs coming up. Also, the Asian Celebrations program that's going to highlight cultures at this point, we have 3 coming up. In March, we have the Persian culture. Since they start the new year on the vernal equinox, the spring equinox, and we'll have a program on India on the 9th of April and the spring blossoms of Japan on the 14th of April. And of course, many other things before then. So thank you very much for joining us and have a lovely rest of your weekend.